Did you know that sum and difference formulas can be used in trigonometry to find the exact value of a trigonometric function and simplify trigonometric expressions? And that these formulas are used in everything from music theory to engineering? In this video, we'll walk through a lot of example problems so that you can see how to apply these formulas. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. We're going to look at two types of sum and difference formulas or identities. We're going to look at formulas for sine and cosine and formulas for tangent. Sine of alpha plus beta and sine of alpha minus beta are written in terms of sine and cosine, and there's a sine and cosine in each term. When alpha and beta are added, the terms in the formula are added, and when alpha and beta are subtracted, the terms in the formula are subtracted. Cosine alpha plus beta and cosine alpha minus beta are also written in terms of sine and cosine, but there are only cosines or sines in each term. When alpha and beta are added, the terms in the formula are subtracted, and when alpha and beta are subtracted, the terms in the formula are added. The way that I've always remembered these formulas is that sine of alpha plus or minus beta has mixed terms in it and the same sign, and cosine alpha plus or minus beta has the same terms in it and opposite signs. Let's now look at the formulas for tangent. I won't go through the derivation, but it starts by setting tangent equal to sine over cosine. The formulas that we just found for sine alpha plus or minus beta and cosine alpha plus or minus beta are substituted in and manipulated algebraically, and the formula ends up as tangent alpha plus or minus beta is equal to tangent alpha plus or minus tangent beta divided by 1 minus plus tangent alpha times tangent beta. Notice that the signs in the numerator are the same and the signs in the denominator are opposite. In the first set of examples that we'll do, we'll use an addition or subtraction formula to find an exact value for a trigonometric expression. We'll begin by finding the exact value for sine of 105 degrees. Our strategy is going to be to let 105 degrees be the sum or difference of two angles that we know the value for sine and cosine, and those angles are on the unit circle that I've included here. I've found that to choose the two angles, it helps to first write down a list of known angles on the unit circle, going from 30 to 180 degrees, and then from 180 to 30 degrees. We can use the list on the left if we're adding angles, and we can use the list on the right if we're subtracting angles. We'll begin by writing 105 degrees as the sum of two angles. If we look at the list on the left, we can see that if we add 45 degrees and 60 degrees, we'll get 105 degrees. So we'll write that 105 degrees is 45 degrees plus 60 degrees. We could have also written this as the difference of two angles, but writing it as the sum of two angles is easier. The sine of 105 degrees is then equal to the sine of 45 degrees plus 60 degrees. Our sum identity is sine of alpha plus beta is equal to sine alpha cosine beta. See how the terms are different? And then the sign stays the same, so it's plus cosine alpha sine beta. We'll let alpha be 45 degrees, and we'll let beta be 60 degrees. This tells us that the sine of 105 degrees is going to be sine alpha, which is 45 degrees, times cosine beta, which is 60 degrees, plus cosine alpha, which is 45 degrees, times sine of beta, which is 60 degrees. Let's now plug in the values. Sine 45 degrees is root 2 over 2. Cosine 60 degrees is 1/2. And then cosine 45 degrees is root 2 over 2. And then sine of 60 degrees is root 3 over 2. This gives root 2 over 4 for our first term and root 2 root 3. We're not going to combine those. Divided by 4 for our second term. We see that there's a root 2 over 4 common to both terms, so we'll pull it out. So we have a root 2 over 4, and that leaves us with a 1 plus root 3, which is our final answer. Let's now find the exact value of cosine of 15 degrees. Since 15 degrees is a small number, we'll look to see if we can write 15 degrees as a difference of two numbers. Looking at this list, you can see that we have a lot of options for numbers that we can subtract to get 15 degrees. It's usually best to go for the smallest ones because those are angles in the first quadrant, and we know those values a lot easier than values in other quadrants. I'm going to choose that alpha is 45 degrees and beta is 30 degrees. We can write cosine of 15 degrees is going to be cosine of 45 degrees minus 30 degrees. Our difference identity is cosine alpha minus beta is equal to cosine alpha, cosine beta. See how both terms are the same. And then we switch the sign and we add sine alpha, sine beta. And let's make a note that alpha is 45 degrees and beta is 30 degrees. This gives us cosine 15 degrees is equal to cosine 45 degrees, cosine 30 degrees, plus sine 45 degrees, sine 30 degrees. Let's now plug in our values. Cosine 45 degrees is root 2 over 2. Cosine 30 degrees is root 3 over 2. And then we add root 2 over 2 times sine of 30, which is 1/2. This gives us root 2 root 3 over 4 plus root 2 over 4. We'll bring out a root 2 over 4 just like we did in the last problem. And we have a root 3 plus 1. And we have our final answer. Okay, so we did the first two, which were the easier ones. Now let's tackle the harder one. Evaluating tangent of 5 pi over 12 is more complicated than the first two problems that we did because our angle is written in terms of radians. Finding two fractions that add up to 5 pi over 12 is difficult. I think the best approach is to convert radians to degrees for these types of problems. We'll just remind ourselves that to convert from radians to degrees, we need to multiply by 180 degrees divided by pi. Let's now do that. We have 5 pi divided by 12, and to convert it to degrees, we'll multiply by 180 degrees divided by pi. Our pi's are going to cancel. And then when we multiply 5 times 180 and divide it by 12, we get 75 degrees. Let's now look at the column of numbers on the left and see which two numbers add up to 75 degrees. Those two numbers will be 30 plus 45. We can write the tangent of 5 pi over 12 is equal to tangent of 75 degrees, which is equal to tangent of 30 degrees plus 45 degrees. Our sum identity is tangent alpha plus beta is equal to tangent alpha plus tangent beta. Notice the signs are the same. And then we divide by 1. Now we change the sign, minus tangent alpha tangent beta. And let's make a note that alpha is 30 degrees and beta is 45 degrees. This gives us tangent of 5 pi over 12 is equal to tangent alpha, which is 30 degrees, plus tangent beta, which is 45 degrees, all divided by 1 minus tangent 30 degrees times tangent 45 degrees. Let's give us a little bit more space. When we evaluate tangent, we can think of it in terms of sine and cosine. So tangent 30 degrees is sine of 30 degrees, which is 1/2, divided by cosine 30 degrees, which is root 3 over 2, plus tangent 45 degrees, which is 1, because sine and cosine are the same. And then we divide all that by 1 minus tangent 30, which we just found, 1/2 divided by root 3 over 2, times tangent of 45, which is 1. Let's see what cancels here. Our 2's are going to cancel, and this becomes 1 divided by root 3 plus 1 on the top, and 1 minus 1 divided by root 3 on the bottom. To clean this up, let's multiply both the top and the bottom by root 3. Let's come over here. This gives us a value of 1 plus root 3 in the numerator and root 3 minus 1 in the denominator. And that's our final answer. Hang with me. We just have a few more problems to do, and they're different than the ones that we just did. The second set of examples that we'll do is to use an addition or subtraction formula to write the trig expression as one number and then find its exact value. So we have two things that we need to do. In our first example, we have a sine alpha and a cosine beta plus a cosine beta times sine alpha. And we know that that's equal to the sine of alpha plus beta. Our alpha is equal to 18 degrees and our beta is equal to 27 degrees. The expression that we're given is then equal to the sine of alpha, which is 18 degrees, plus beta, which is 27 degrees. This gives us the sine of 45 degrees, which is equal to root 2 divided by 2. Let's now look at our second example. This example looks like a cosine-cosine plus a sine-sine. So we'll write this as cosine alpha, cosine beta, plus sine alpha, sine beta. And we know that that's equal to cosine alpha minus beta. Let's make a note that alpha is 3 pi over 7 and beta is 2 pi over 21. Our expression now becomes cosine alpha, which is 3 pi over 7, minus beta, which is 2 pi over 21. Let's do a little arithmetic off to the side here. We have 3 pi over 7, and we're going to subtract 2 pi over 21. We can get a common denominator of 21. So the 3 pi gets multiplied by 3, so this gives us a 9 pi on top, minus 2 pi, and this is equal to 7 pi over 21, which nicely reduces to pi over 3. Our expression is then equal to cosine pi over 3, which is equal to 1/2. Hang with me. We have one more to do, and it's the complicated tangent function. Let's write down our formula. We have tangent of alpha. Now we need to think about the sine. Notice that we have a minus on top and a plus on the bottom, so that means we're going to choose it to be a minus beta. So tangent alpha minus beta is going to be tangent alpha minus tangent beta, all divided by 1 plus tangent alpha tangent beta. Let's make a note that alpha is 73 degrees and beta is 13 degrees. Our expression then becomes tangent of alpha minus beta. So this is 73 degrees minus 13 degrees. This is equal to tangent of 60 degrees. So we can think of this as sine of 60 degrees divided by cosine 60 degrees. Sine of 60 degrees is 1/2. Cosine 60 degrees is root 3 over 2, which gives us an answer of 1 divided by root 3. I hope that you now feel more comfortable with sum and difference trigonometric identities and feel ready to do some of these problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.